Well, welcome everybody to GWAMA. I know that we just did the groundbreaking ceremony, and that's great. The folks right here, working with me right here, is my Algebra II students. Part of the cool things about GWAMA is that we get to do cool projects and fun things in math and in science, and of course in the welding academies. One of the main projects that we did for the end of the year for the Algebra II class is the weather balloon. I decided to teach some math concepts, not with worksheets and not with books and paper, that with an actual project where the students did math. We calculated how fast it's going to rise with the amount of helium, how fast it's going to be falling as it's coming down, how far it's going to travel, and where it's going to go. And so I figured, in my personal opinion as a teacher, it's a better way to teach math that way than to doing worksheets on pen and paper. So we'd like to go ahead and get started. First, I want to say thank you to a few folks, namely Train. They gave us the big donation for the weather balloons. In addition to that, Matheson Gas supplied our helium for today. Dupuy Oxygen also gave us a donation, and Texas Metric and Devices gave us some donation for this project. So this wouldn't be happening without our business partners, and so we thank you for helping us out today. And the kids learned a lot just from y'all's donation, so we really appreciate it. So we're going to go ahead and get started. The balloon that we're going to be doing is going to go up to 112,000 feet. It's awfully high. It's near space. We're going to be able to see the curvature of the Earth. The space will be black. It won't be blue above us. We have a camera pointing down, and we also have another camera pointing to the side. So we're going to be able to get lots of data. We have one of our balloons has an electronic device that will capture the temperature, the humidity, the infrared light, the visible light, the air pressure. So we'll be able to get lots of good data, and we might send that data over to our friends at SpaceX, see if they need any of it. So, yeah, without further ado, we're going to go ahead and get started. Let's do the morning group first, guys. So let's go ahead and get rolling. So this is our first time doing it, so we've kind of done some dry runs. We've kind of thought through the whole process, but it might be a little minute. So once a balloon gets up to the height, it's going to pop, and then it's going to float back. And we've got a GPS device that we're going to go track it with our phones and apps, and we're going to go find it. So we'll be leaving here about 30 minutes. We also had to contact the FAA to let them know that we're doing this, so they know this is happening. That's right. And just crack it. Yeah, I think so. It's going to be about 8 feet diameter, 7 to 8 feet diameter.
How long does it take us to that?
We'll see. I don't know. Go ahead and keep going. Crack it a little. Not too much, not too much. Are you feeling any pressure pulling off from you? Okay. Hey Garrett, go ahead and fluff it out a little more. Okay, so once you feel it, I think we're going to use the whole tank. But if you're feeling, if it's wanting to go up a ton, we might want to start backing it down. Okay, how's it feel? Like, are you pulling down a lot? Huh? Are you pulling down a lot?
Yeah, kind of. Now.
Okay, go ahead and slow it down. Slow it down. All right, so how's it feel? As in, like, if you let go, it's gonna go like super fast, or is it just gonna be?
Yeah, it don't feel like it.
Really need to make sure you hold it with both hands.
Yeah.
Keep letting go.
Yeah.
If that thing
Yeah.
falls off.
Tell me when we get to 8. Let me know. I know. We need to get to. We're gonna wait for 8 feet diameter, so don't let go. So right now, we're waiting until this gets about 8 feet in diameter. And when we let it go, when it gets up to that 112,000 feet, this balloon is actually going to be about 41 feet in diameter. So it's going to expand an enormous amount. That's why they're using latex gloves, because it's such a thin material. If they get any oil on their hands, the oil on their hands, if they get that on the balloon, it'll deteriorate it. There's a potential chance that it'll pop sooner. Derek, what about all those football practices? Come on, man. What are all those days working in the gym? Come on, man. Two hands, man. Two hands, two hands, two hands, two hands.
What is that?
It's probably just condensation on the inside from the helium, maybe.
Hope so.
No, that's where it bounced off Derek and your head already.
Nah.
Three spots.
think so?
Jelly
Be
back
alright.
your hair.
Be alright. Alright, guys. Okay, cut it. Alrighty.
So where's the tension tool on this thing? The parachute?
To there.
Let go with one hand. Grab that.
That's all right. All right, here we go. So let it. So when you let go, hold onto the rope and light slowly and get it taut. You're the last person to let go, okay? When everything's taut, straight up,
And you feel it.
whatever, taut, tight, whatever. So when it's, so you slowly go, okay? See, that's why we locked down the camera. Awesome.